All right, let's get started. I have copied day 6 to day 7. I'm doing all this manually right now. Maybe in some future iteration, I will not do it so manually. That's day 6. We're on day 7, aren't we? Kind of some cool news. I decided to publish all of my code and solutions to these problems to GitLab. So those are up on GitLab, accessible. I'll share the GitLab repository in the video description when I'm done with this one as well. But that way, if there are questions or if you're trying to follow along, maybe you don't have the same input that I have. There was a question earlier today about what input I used. Those will all be available to you. So the idea is that I'm providing that information, not so that you kind of have the solution, but if you're struggling to walk through the solution, you could walk through what I put together. Advent of code is great. I've been doing it for like this is my 3rd year, I think. And I think everybody who is a developer or software engineer or principal engineer, or you develop software, everyone who develops software should attempt some level of Advent of code every single year. I particularly choose Advent of code because it's 25 days of growing my skill, learning, and really more about not can I program, but how do I solve problems? And each year that I do this, I get a little bit faster, a little bit better. It's more about thinking through the problems for me than it is about just coming up with a fast solution. And it allows me to flex some of the skills that I use, maybe not necessarily on a daily basis, but then sometimes when I approach a real world problem, I may not think back to exactly Advent of code, but I know I've solved that kind of issue before. Things like map traversal or grid traversal or node traversal or a parent tree node problem. I would not be surprised if we see one of those here on day 7, where we have some sort of node association. So if you're not doing Advent of code, or if you're not following along, I highly recommend that if you are at any level of software engineering, that you start digging in and trying to just kind of tackle these problems, tackle these challenges. Are they all real world problems? No. But do these types of things manifest in the real world? All the time. And so at the very least, it gives you something to exercise on and explore, and kind of give you a better sense of reality when it comes to how you might apply certain things in certain scenarios. So I'm thankful for Advent of code, and I'm going to continue to do it just so I can continue to flex my skills. So what are we doing here? We're waiting. I start this stream 15 minutes early just to kind of get prepared, make sure that I'm ready to go, make sure everything is in place, and answer any of your questions. So if you're here, first off, I'd say please like the video if you haven't already. Oh, okay. Well, thanks for letting me know. I can get rid of those. Did not realize that the inputs were protected by AOC's copyright. So I can get rid of those in my outputs. Appreciate that. Do you know where that's located? Maybe I should go take a look myself. Do you have a link just to that copyright claim or not claim, but documentation? I just want to make sure that I'm not sharing something that I shouldn't. I'll tell you what I'll do. I will make my GitHub repository private for right now. That way, they're not shared, and we can go from there. Let's see here. Yeah, let's see here. Change to private. Oh, 1 second. I'm making it private right now, just so we can kind of go through this. I didn't realize. 0. All right. I have now made the repo private until I resolve that. Thank you for pointing that out. I just wanted to make sure. I'd be interested to read that. I don't mind sharing the code, but if I can't share the input, I don't want to do something that is against policy. So I appreciate you pointing that out. But yeah, if you can share that with me, I'd appreciate where you saw that. I honestly didn't really go through it a whole lot, so. Yeah, let's go through this real quick. Maybe it's in here. Can I stream my solution? Yeah. Here it is right here. Yeah. So here's the little blurb right here. It's just asking that we not do that. So, I might share with person from time to time. Appreciate that, Mariano. I might share with somebody from time to time if they ask, but I won't post it by default. This is, I didn't realize this was in here and they asked us not to share that input. So I won't. So if you have a particular question about it, or you're having an issue with a particular problem, I can share that with you. But I'll repost my repository publicly once I remove the text files. I'll just add them to the git ignore and wipe them from the history and then redistribute it for more public consumption. That way, at least you'll have the solution and can walk through it if that's something you want to do. If you're having issues with your own process, etc. But okay. So that's that. Right. So we've got 5 minutes left. Do we have any other questions, any other observations? All right. Well, let's see. Yesterday I did make some changes to day 6 after the stream. I optimized a little bit. One thing that I was doing in part 2 is I was copying and creating new instances of the matrix every time. But I realized that all I had to do was modify a particular position in that matrix, run the test, and if it came back as invalid or a infinite loop, then I would increase the score, and then I would go on to the next bit. The other thing I did was I collapsed the duplicated logic back down into just get visited, and I thought to myself, well, really being an infinite loop is an error condition, and so I can get back the unique positions visited, but then also return an error if we are in an infinite loop. And so that's what this approach does, is that it returns back an error if we find that infinite loop condition, and then part 2 just simply uses that same function and looks for that error condition. Oh, day 6, part 2. Yeah, I can cover that really quickly. So, part 1, you didn't ask about part 1, but part 2 essentially uses that same logic. But what I do is I run against the original state of the input. I run the get visited track first, and I get a unique set of all of the things that are visited in that first set. And then what I do is I range over that visited list, and I say for each point that we visited uniquely, let's create a blocking condition there and rerun our visited loop. And if that visited loop is found to be, if that new blocker puts us in an infinite loop, then I exit with an error. And the way that I'm determining if we're in an infinite loop is I check the given position. I check to see if it is a blocker. In this case, this is a guard clause. But if it is a blocker, then I log it in this tracer. I just call it tracer in my refactor, but in this tracer map. And if it is ever in there on a second iteration coming from that specific direction, so it's not just the blocker, but it's the direction that you're coming into that blocker from. Sorry, my son's getting ice out of the freezer, but it's the direction that blocker is coming from. And so if that's true, if we see it for a second time, we know that we're in a loop. We know that if we got back to that same blocker from that same direction, we've infinitely looping, and so we're going to return. The first attempt at part 2, I should say, I didn't look at just the original visited set. I went through and brute forced to input a blocker in every position that a blocker was not present to see if that would return true. And on my Mac, that meant I ran the final test in 7 seconds. But with only looking at the visited set, I run in about 1.5 seconds for part 2. So much larger optimization. Maybe we could do some benchmarking in the future, but I cut the amount of tries that I'm doing on the final set down by a lot by only looking at a subset of change grids or a smaller set of change grids. All right, we should only have a few seconds here, 45 seconds. 1 second. So, right. So we got 32 seconds left. Do you have another question on part 2 by any chance? I might be able to answer that briefly. Otherwise, I could revisit it at the end. Nice, nice, nice. There's a lot of factors there too. Depends on the machine that you're running on. I'm actually using MacBook Air, like a 2022 MacBook Air with an M2 processor. So it's not really even like a beefy machine at all. All right, part 7. Day 7, the bridge repair. The historians take you to a familiar rope bridge over a river in the middle of a jungle. The chief isn't on this side of the bridge, though. Maybe he's on the other side. When you go to cross the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross it until it's fixed. You ask how long it takes. The engineers tell you that it only needs final calibration. But some young elephants were playing nearby and stole all the operators from their calibration equations. They could finish the calibration if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equation. So your puzzle. Each line represents a single equation. The test values appear before the colon on each line. It is your job to determine whether the remaining numbers can be combined with the operator to produce the test value. Okay. So operators are always evaluated left to right, not according to the precedence rule. Furthermore, numbers in the equations cannot be rearranged. Glancing into the jungle, you can see the elephants holding 2 different types of operators, add and multiply. Only 3 of the above equations can be made true by inserting operators. So like 10 times 19 is 190. Choosing plus would give 29, but choosing multiply would give the test value 10 times 19 equals 29. 81, 40, 27 has 2 positions for operators of the 4 possible configurations. Operators 2 cause the right side to match the test value, and both equations equal 3267 when evaluated left to right. Hold on a second. Okay, so that's 2 possibilities. can be solved in exactly one way. 11 plus 6 times 16 plus 20. The engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. In the above example, the sum of the test values for the three equations listed above is 3749. Okay, how's that come out? Is that 3267 plus 292 plus 190? Determine which equations could possibly be true. So even though this one had two possibilities, we only included it once, and then there are some that weren't possible at all. Okay. Interesting. Okay, and then what's our puzzle input look like? I'll try to do this a little bit more, but we don't have like a crazy number of items to the left of each. So let's just go in and grab this now since I'm looking at it, and we'll put it into our 1.txt, and then we'll go back and we'll grab our test result. And we'll plot that here. And so let's think about how we're going to approach this. So we could take each approach. We could do 10 and 19. We can just simply try the multiplication operator. We could try the addition operator. When we get here, we're going to have to try all the possible combinations of multiply these two, add this one, multiply these two, multiply this one, add these two, multiply this one. So we have a couple different possibilities there, and we're trying to figure out if it's going to equal the number on the left here. So let's see here. I think what we can do is if we do like 10 plus 19, we do addition. If we do addition, we can check. And if the number with addition is higher, then we already know that it's not going to work. If it's lower and we get to the end, we have to come back to multiplication. Trying to think of a way of which we don't have to create every possibility, but maybe the answer is that we just try every single possibility. If we try addition across the board first, and then once addition doesn't work, we try multiplication, but we're going to have to do, like on this one, it would be addition, 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 multiplication, addition, addition, multiplication with addition and addition, multiplication. And then once we get to the end, if we're still not there, then we would do two indexes of multiplication. So multiplication, multiplication, addition, and then multiplication, multiplication, addition. At any time we exceed our value, we know we've gone too far. And then finally, the last one would be 3. It would be whatever the length is minus 1 would be the maximum number of multiplications that we would do. And then I think that's how we could iterate through. We just kind of that's our brute force approach. We just kind of slide these mathematical problems forward. And so let's take that approach. So we've got this input, and we know that there's a colon. Input's a little bit interesting, but that's okay. I think we can separate it with the colon, and then we can do total is going to be our string convert a to I. And our input is going to be M. Actually, this will be 4 row in range of m and this will be r sub 0. And we will just toss the error because this is not a real program and we're just going to assume that we're right here. This is going to give us the additional spaces over here. And actually, I'm going to do a colon space for our parsing just to get rid of that first space there. And then our numbers to evaluate are going to be let's see here. So that's going to be r sub 1. And is there a matrix that has 2? Where's that function I have in here? There you go. Common.asInt. That's what I wanted. So I can take and convert these to ints. So it's strings dot split because we have to split the second values on a space. So that will simply be that. So we're going to take that, we're going to split it. Now we have our numbers, and really, how do we want to articulate? How do I want to articulate what the loop is going to look like? So the operator is always going to be a addition, right? We can say for subtotal is less than total, and we'll call subtotal 0. And so while subtotal is less than total, and then maybe we can do, okay, so how do we just like add these ints up, right? So, well, if we were to do just the addition, it would be num plus equal, actually we can call it subtotal plus equal num. So that's our addition, right? Now, that'll just give us the total, and really I just want to do that. And then what I'm going to actually do is I'm going to say if subtotal greater than, so we don't want to just exit when that is true. Man, how do I want to think about this? Let me look at one thing here. There was something that was said 81 plus 40 times 27. So is that truly 81 plus 40? Yeah, it's times 27. No. Yeah, it is this, right? Yeah, okay. So it's doing the addition first. It's not doing it in like PEMDAS order. So what we want, we can, that's actually better for us. Man, it's, I almost want to just create a set of operations which returns a slice of string, and the operations are going to be because I could just build these out ahead of time. I think they're relatively cheap. I think this is the like just get it done approach here, and I'm going to go with that. So if I do that, then I can say, okay, for we're going to have an input, which is going to be a in, which is the list of integers. And so what we want here is the length of int I don't like this because we're creating like a slice of like operations. We're pre-doing that. Instead, I think we can actually figure this out a different way. So what I know is on the first pass, if I have some sort of iterator and that is assigned 0, right? Then I know all of these are going to be additions. And if I have a second operator, also 0, I can calculate this by the number of times I've looped, right? So I know in maximum, I'm going to have one iteration for all addition. And then if it's a size of 2, I'm going to have one iteration for multiplication. I know then that at the second iteration, it's going to have to be a multiplication. And so, I kind of have like two approaches in my mind, but I feel like this is the better approach. We just increment, right? So okay, so multipliers is going to all right, let's do this. If subtotal equal total score plus plus break. So we're done with this one. We've got the score. If score greater than, if subtotal is greater than total, we just break. Okay. So let me just do addition slightly separate from multiplication. So now, if I know I'm going to have a multiplier, right, then at this point, I equals 0. Oh, okay. So we could do 4i equal 1. I is less than the length of numbers I plus plus. We're going to do that. So that will give us, we know that what did I? Something's wrong here. Oh, let me just get rid of this for right now. Okay. So we know that we are going to have at least that many multipliers at most, right? We actually want this same condition. So maybe we could wrap this up above, but I'm going to utilize this same block here, and I'm going to place it here. Yeah. Actually, yeah, we're going to do multipliers are 0, and I'm going to undo this, and I'm going to undo this, and I think that will be okay. I still need that. Right, so score is not here, so let's fix that. Right, okay, score's in place, and we're gonna do score here. So now the question becomes for this, what we know is how many multipliers we're gonna use, but depending on how many multipliers, it's gonna indicate how many times we need to loop this, right? So if we've got one multiplier and we have a length of 2, we know that we only have to go like kind of slide through here only once. And so what that's going to mean is that on the first iteration, we don't have any multipliers. So that should handle additions just fine. Okay. So let's I see in my head what I want to do, and I'm trying to think about how to like articulate this in code, right? So I know that the multiplier positions are going to be 0 the first time through, but I want to slide that in a sliding window, those multipliers forward through this, right? And so instead of them being additions, I want them to be multiplications. But I only want to do that when I have multipliers. So like in a 0 condition, I don't have multipliers. And I'm wondering if that is making my life a little bit more difficult by having the additions in here. But what I could do is, so if our I is So I becomes 1. So then I know that, well, if we use I as the index, which would be better, then this is only multiplication, right? I is the index offset. Yeah, let me just break these apart. I'm going to keep them separate, and we're gonna call this main. I'll give it a tag, and we'll break main here. And we'll break main here. That way we can just break out of the whole for loop for that particular like record if we get an answer. But that way I could just keep this as multiplication. So we know that if we get here, we're at least multiplying, and we're going to start at the index 0. So if I equals to j, then our subtotal is going to be well, let me go back to this. Oh, I guess I erased it. It is 81 plus 40 happening first, right? Then times 27, which gives us our, yeah, because we got to put this in parentheses. If I could figure out how to type it on this keyboard. 3267. Okay, so that's good, because if this is true, then this is times equal or num. And that's going to, this right here just handles like a 0 case, the first thing being multiplied. So I equal j. And then the problem is, though, that we don't need just one of them iterating. It doesn't need to just be that index, but it needs to be, okay, so okay, so then we can create another one of these. We'll call it j, and this will be for the slide. And so what this will do is it'll allow us to create a variable to slide that window forward. So we know that in each iteration, this is the count of, we'll call it counts. The M count, MC, is the MC for the night. The multiplier count is probably, I don't know if I'm on the right track here or not. But that is the multiplier count. So that is, we'll call this, actually, we'll start it at 1, and we'll go to the length, or less than or equal to the length. Let me think about that. So the multiplier count should never be greater than 1, right? So the length should be in a 2 slice, it should only be 1. So that's fine. So it could be this. And then this is the number of times that we are going to iterate. And then the number index is the number that we're in. So then what we can do is we can say, okay, this will give us an idea of where we are sliding in that window, right? So 0 is at the 0 index, and we are going to have a multiplier count of 1, and then we iterate forward to the 1 index, multiplier count of 1, so forth. So I think what we can then say is that if ni is greater than or equal to j, and ni is less than j plus our multiplier count, So J will always be the index we're in, and this is how many multipliers we're going to move forward. So if J is 0 on the first iteration and we have a multiplier count of 1, the NI has to be at least 0, and then it has to be greater than the multiplier count. So I think this will allow us to slide forward and kind of keep sliding forward, and only if the subtotal is over a certain number will we see our result. So let's just run a test here for day 7 and see what we get. Okay, so our input, did we put our test input in place? Let's see here. Let me close all these. I usually do this at the beginning and I forgot. Oh, that explains it. Our test was not saved. So now it is saved. So let's try that again. And let's see if we get somewhere here. Okay, so we threw an error, parsing invalid. Okay, we'll look at that in a second. That's with the test 190 colon. Okay. Let's see what we got here. So if we are parsing on colon space in our test input, let's go ahead and we'll do a print line of m.pretty, and we'll rerun this because I'm just kind of curious what our output is. Okay. So this is each row. Okay, but 0 should be 190 now? Where am I getting this error? Strings.split. Okay. What is this about? 32672781. 326. Did I just miscopy the input text? I'm going to say I botched that real quick. And let's see if that is better. Okay. It's better. Okay, so we're not blowing up, but we don't have a score. So our expected score should be 3749. So let's go with that. And then let's go back to see how we're keeping our score. So we know if our subtotal actually our subtotal should be blanked out each iteration up here. Let's see what we got if we rerun that. Expected 49. And then our score should be plus equal our subtotal. still not clear. Yeah, let's do logarithm.info f. We'll get some labels on here just so I can see a little bit better. And then we'll go with make sure all that's working. Okay. Okay. 119, 1019. Okay, perfect. So for num in range of numbers, subtotal, if subtotal equals the total we're looking for, score plus equals subtotal. Okay, I think that's probably working. If subtotal greater than total, then we break. It's terrible to log, but I'm going to go ahead and go with it. Too much add. Okay, I'm not seeing that. So we know that we're getting through this. So we're not getting through this. Too much multi. Okay. $11 times 6 times 16 times 20. Okay. What about 10 and 19? Subtotals. Oh, subtotal is 319. How do we get to 319? It's 10 times 19. Okay. So the subtotal each time needs to be 0. Let's just reduce this down to just like the one problem, because we know that this is way off. So why is it that I'm getting 760 here? That's way off. So if my multiply count starts at 1 and our multiply count has to be less than the length of numbers, and we do an MC++, and then Is this supposed to be zeroed out here instead? But still, something's not jiving a little bit. 209. Okay, it's a little bit better. Oh, because I need to else this. Or instead of elsing, I will do continue because I prefer that. Construct. Total is 190. Okay, that's great. So then if I put back the original test input, that's taking a really long time. Exceptionally long time. Okay. Let's look at the timing here. So these all went really fast, including this one, which has multiples. 156 was the last one. And then we got the 7290 and took a really long time. Okay. Way too long. Okay, so why? Why at 4 did we take that long? So we know that our multiply count is going to be 1. It's going to be 2. And it's going to be 3. So we're going to try those 3 iterations. And then for each of those, we have a number of them that is going to happen. So we know on the first iteration, it's going to be 1 of them. Second iteration, third iteration. We're going to move that index forward. Let's do this. Trying MC at J. Let's just see what this puts out, and let's do like a 1 second runtime here on the test. I'm just kind of curious what I'm getting here. Why is the MC... Do I not need to do this for loop? Am I crazy here? Did I add an extra for loop for no reason? Is that what's going on? Is that this one's actually failing? And it's going, okay, I think that's what it was. This one was actually failing because I had the extra for loop for what reason? I think I was going a different approach here, or slightly different approach, and then I landed on this. And so, awesome. So let's take our input. I think I actually already brought it in here, and let's run. Yeah, the second test is going to fail, or the sec part 2 is going to fail. So let's go with that. That's not the right answer. Okay. Right. So then the question becomes why? What did I miss? What is not right? We are breaking this for loop if the subtotal I'm actually going to call this multi, and I'm going to break this. I am going to break out of that because I want to, if we get to a subtotal that's high, like there's no reason to keep going. Well, that's interesting. Okay. Um, okay, I'm wondering if, so I know if our subtotal is greater, we want to break out of, do we want to break out of anything? Does it make sense to even catalog this and break out of here? Um, if we've got the subtotal, right, we want to break for sure. That I know. But if our subtotal is too great, do we want to break it all? Because we're just going to iterate back up to the top here and reset our subtotal. Okay. This is technically part 1, even though this is part 2. Okay, let's go back to our test. Let me do 10 seconds here. Okay, so our test is still fine. So what's unique about the test data that we're missing? Our input data. Are there negative numbers maybe? Did I? No, there's no negatives. There's no situation I can think of where adding okay. Let's slow down here and let's see. There's probably something very obvious that I'm doing wrong. Okay. So in all my test cases, this works, but let's look at with AOC and their examples. We have addition and multiplication for 292. We have addition and multiplication two separate ways here for that. What we don't have, we have an example here. What would be the case for this, but this, but then this is in parentheses here and here, and this is multiplication 660. So if we took this and we added a $660 minus 3749. Okay, so what that is, that's the condition where the multiplication is at the very end. But wait a second, these don't have multiple multiplications in here. So let me add another test case. Let me add this where this is all multiplication. I have to multiply every single one. 21, 120. So we said 21, 120? Yes. That's 21, 120. Okay. What about if we did something like $55, $40? All right, $54.40. Okay. That seems to all be working correctly. So what am I missing here with 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 this process? I'm a bit lost. I'm getting back all of the scores I'd expect to get. And yet this is not seeming to be right. So, oh, wait a second. I can't break multi. Break multi. Let me do something real quick. Let me functionalize this and see if that helps. So numbers, just because I might be getting lost here in these loops. And it will help just to return the value. I think we're missing. There we go. Right. So can this be that? And then we can call and this will be total numbers, something like that. And if I run the test, still passes. Still the same value. Let's change this log. And we're going to change it to found total. Percent %D, percent %J for percent pound v, which would be numbers. What's wrong with this? Total. This should not be a break. That should be a continue. That might be why I'm having an issue. Because no, we don't need these anymore. Yeah. So I think that was the issue. I found the problem. So what was happening was the initial test input for advent of code day one, which tripped me up, didn't have any pure addition parameters. So if I go back to what I was doing, right, we'll do some like TDD, test driven development here. If I go back to my test input and I add this and I add this and I say 29, so that forces 10 and 19 to be an addition, this will just return actual 219 because that is this. Once it hits a plus condition or a addition condition, it exits completely. So that was the bug that I was tracking down that hugged me up for a while. Instead, what we want is this. The actual value should be this plus 19, which is 3988. 3988. So if we go back to our test here, if I change this to 3988, I think, and then I go back and I fix my problem. Instead of doing a break here, I do a continue. I think, again, that was just from my wanting to go back and forth. 3998. I'm sure my dyslexia. 30. It's fine. I mistyped something somewhere, I'm sure. Okay, let's actually run it. Already going kind of slow here, but this is our value. Let's go. Okay. Not our value. It's 29, not 19. That's why I had the numbers messed up before, because I added the wrong value. Okay. So why is this not our value? too much add. $557. 556, that's true. Okay, let me see here if there's a problem in here. So if our subtotal, if this, we're continuing to the next number, and we're multiplying, otherwise we're adding to our subtotal. And we're only seeing if our subtotal matches here, otherwise we're returning 0. Man, I am unsure. I've added the multiple test cases. I guess I could break down these test cases further, and I could do like very specific expectations, but I feel like I have a pretty good coverage here. Thing is, I'm not clear on like each test condition, right? So I know I've got multiply, I know I've got addition, I know I have a couple other examples of all multipliers, some multipliers. I feel like I'm just missing something. This was definitely a part of it. So if this is true, we are going to continue to the next record, in which case we get a new total and we get a new set of numbers. We reset our subtotal. And if we have too much from, oh wait, there's the other condition. So if we had too much add, we were breaking. So let's look here, and let's add that test. Jeez, sorry guys. It's late. It's day 7. This right here should not break my test, but it's absolutely going to break my test. Yeah, okay. So now if we switch this to a continue, because we know when we have adds, and now we should get the right answer. Man, okay, this is it. This has got to be it. One other idea here. What is the largest int 32 value? It is 2147483. Golang int default type. That is 64. Yeah, I think we're okay. Maybe. It says that if you're on a 64-bit system, you should be using N64 otherwise. But maybe I can just be sure by doing a, let's be implicit here. I don't think this is my problem, but I'm about to be sure here. Why is subtotal an int here? Oh. Whatever. We'll just do var total. Yeah. All right, let's just see if that changes the results. Yeah, I don't think so. They look the same. Kind of sad. Okay. So what am I missing? What else am I failing on here? What are the other possibilities? So let me create a function. Let me create a test because I think the addition is pretty straightforward. what I need to do is test get multi-score. And I need to be able to test these conditions a little bit more explicitly. So I'm going to kind of just copy this template, and I'm going to call it test multi. Sure, and we'll rephrase it to be that maybe test get multi-score, and then we don't need an input file. Instead, we have our function, which is going to be this pattern here, which we know what the function is, so we really actually don't need to define that. And instead, it's going to be this, and it's going to be test dot, we'll call it total, and test dot numbers. And so we'll put total, we'll call it int 64, and numbers, it will just be a slice of ints, so that when we call that, we can just create a table like driven approach here. And so we'll say our expected is let's grab 190, and our well, I guess like expected and total is going to be the same, so we can just do test.total. Kind of weird, but it'll be okay. Numbers, and we'll create a slice of ints, and we'll put in 10, 19, right? Is that what we have for our first test here, 10 and 19? Right, okay. So if we run this, get rid of that. Okay, so that looks good. So let's give it a name, which is just a string, and we'll call this and so maybe we'll create a 10, 19, 22, 34, 11. And we'll say all but last multiplied. And so if I take this and I go here, and we'll create parentheses here and here, and we'll do a plus sign, and then it's got to be multiplied, multiplied, multiplied. 142, 131, 142, 131. Okay. So now if I run this test again, that passes. So that's with all of these multiplied except for the first one. So now if we do the same thing, what we do I think I just realized the test scenario I'm missing. 14. Oh, I'm sorry. Let me multiply this. Is that right? No. It would be, the parentheses would be here, technically. This would not be parentheses. So it'd be 238, 612, 238, 612. That's, I don't know why I did that. Okay, here's the scenario I'm missing. Not in the test case, but here's what I'm not accounting for. Let's do this one as 1019. Yeah, let's see if this would be it. So multiply addition multiply. This is what I'm not accounting for. Multiply. We'll call this yeah, let me put parentheses here and here. So 79288. So what we're doing actually is we have a multiplication and then 2 further. So what I've done is I've created a lot of scenarios that work, but I'm missing this one scenario where what I'm saying is that it starts at a particular index and then it moves forward from there, and they always stay together sliding forward. But what I'm doing is I'm missing this scenario where we can have 3 multipliers and the second one moves forward all the way to the end and then comes back to the beginning, and then the next one, and then the next one. I'm not sliding the multipliers individually through, so I'm missing those edge cases. So 79288, 79288, 79288. That's not what I want to do. Yeah. So this is the scenario I'm missing. So now that I know that, how do I implement that here? So instead of just stepping forward, I have to step each index pointer forward. And as I multiply, so if I have 3 multipliers and I have 4 possible positions, I have to take the third one and test it at the first 3 positions first. And then I have to take the thirdmost one and move that forward 1 position. And then I have to take the next one and move that one forward 1 position and test the plus in each of the locations. So it's not just sliding the window forward, which is what I'm doing right now, but it is also trying every permutation of the multipliers in the different indexes. So here, maybe if I can do this. This is just the different permutations. So if we go AOC day 7 and we look here and we've got a value here, and we know that one permutation of this could be, let's do that down here. It could be 1 times 2 plus 3 times 4 plus 5. Right now, my algorithm with 2 multipliers only allows for 1 times 2 times 3 plus 4 plus 5, or 1 plus 2 times 3 times 4 times 5, or plus 5, sorry, or 1 plus 2 plus 3 times 4 times 5. It doesn't allow for this gapping of the multipliers being separated like this. And so I have to go through each of those permutations, and that's where my bug is coming from, is I'm not going through each of these permutations here. And so I have to effectively build my lists with those permutations. So man, I'm tired. All right. Well, I know what my issue is. I know what I have to do. So then the question becomes, for each of those, my brain hurts. So I think I know what my multiplier count is. If I can get back a list of all possible permutations for that multiplier count for a set, I know what the answer is. So if we did like a function called like permutations, and we take in multiplier count, which is the int, and a length of int. So we know if our multiplier count is 0, and our length is 1. Our list is empty. We know that if our multiplier count is 1 and our length is 1, our list is empty. If our multiplier count is 1 and our length is 2, our list is 1, which has is going to have index 1, right? It's never going to have index 0 because we're not going to multiply 0. We're always going to have index 1, right? Is that part of the problem? Should J ever be 0? J should never be 0 because we don't want to multiply a subtotal of 0. That may be a separate problem, which is multiplying against itself. Let me go back and read. Yeah, so I think that's also another issue is that J can't ever be 0. J, the multiplier, we never want to multiply at 0. We only want to multiply when we're pulling in the 1 condition. So this has to be 1 as well. I don't know if that affects my tests. Oh, because I'm pseudo coding this real quick. I'm just kind of curious. Test still pass. What does that do to my actual like output though? I'm just gonna try that. I feel like that's a different number. No, it's not. Okay. So I don't know if that actually was a condition I was hitting, but I do feel like it's a potential issue. So if we want the permutations, we need to know at what indexes that we could, like, we just want to return a list of ints. And those will be the indexes of the permutations of the multiplier. So if I think about this, if oh man. My brain is just not functioning right now. I don't know. I don't need well, I do need the multiplier count because I need to know how many. Yeah, this is just a permutation problem. Hmm. Yeah, I think that's what I'm trying to do, Kevin. At this point, I'm struggling. So I figured out the reason I'm wrong is because I'm not generating every permutation. I'm just sliding through with a certain set. I'm not lost. I just am thinking and trying to figure out a way that I can approach it that isn't painful. Um, but yes. And so I know I can loop. Um, there's there may be another way without actually generating the permutations, but I think the easier answer is just to generate the permutation list at this point. But we don't just want like the permutation of like each number. We want the permutation of possible index in which we multiply, and it will be a subset of the numbers. So like for instance, we want to be able to multiply at index 0, 1, and 3, and then 0, 2, and 3, and then at 1, 2, and 3. Because what this is doing is this is basically saying, okay, slide through it and multiply where the index match, and then give us a subtotal. And then this is working. I just am not covering all the permutations. I have the edge case where it's not really edge case, but where you have multiplication, then addition, then multiplication, then addition. And I guess actually, if I had, okay, wait, I think I can actually do this. So if I know my multiply count um, is, okay, so then I actually don't. Yeah, okay, we can take this a different way. This is actually going to work. This is going to be kind of funny. So if we make this a slice of bool, right? And then if we for range of multiplier count, and we just, yeah, true. So those are the things we want to multiply. And then it's length minus the multiplier count. Are the things we don't. Well, why don't I not have? Okay, well, we'll just do for I is assigned 0. I is less than MC I plus plus. It's fine. We'll do it the long way. I need to update. That's okay. I'll do that later. And then this is length minus MC. So the multiplier count's always going to be less. So then this gives us our falses and our trues. Do we multiply or do we not? And then it's just figuring out all the possible permutations of that. And then we'll get a list, and that'll be our total set of permutations. So now that we have that, let's see if I can just like Stack Overflow this then real quick, and kind of be done with it. So just want to see here. Yeah. And then we call permutations on, but this I want to be a bool, and this is bool, 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 and this will be, I need a better name. Results. Yeah. So now instead of this, it will be, we can actually get rid of this, and we can do for range of this, and then this will be, and what we're going to do is we're going to pass in our call this J and multiply, and our permutations are going to be the MC, which is still going to be valid, and then our length of numbers. And then if ni equal to j, so now if they're equal and multi, so if multi is true and our index ni, oh, this is a list of lists, so actually this isn't true. This should be perm for permutation, and then we do what I just did, where it's j multiply range of perm, and this cannot be referenced because it doesn't matter. And then we need another one of these, and I think that will do it. So what we're saying is basically we're going to get this list of permutations of multiply, trues, and falses. And anytime we have that index is a multiply, we're going to multiply. Otherwise, we're going to add it. And see what our test says. 3588 when the expected is 3099. That's for my test parts. Okay. So let's look at what our perms are. True, 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 false, false, true, false, 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 true, 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 false, true, true, false, false, true, false, 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 true, true, false. Something not right there. You know, we don't have to calculate these permutations every time. We should already know what the superset of permutations are. That's another optimization because we can look at the max length and figure out what those are. But that's kind of another point, I guess. False, false. Where's the like false, false, true, trues? Why am I not seeing? Am I just not? Here, let's try one other. Let's create another test here. These should be pretty deterministic. Test, we'll call it get permutation. Let's call it get perm. And so we'll say our multiplier count is 3 and our length is 4. So if we do that, then our expected should be a slice of bool. We'll stick with the names, and our MC and length are ints. And so call this test test.mc, test.length, and test.expected. And so now let's get rid of these for this. And okay, we've got true, 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 false. So our expected should be we want true, 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 false. But then we also want true, true, false, true. But then we also want true, false, true, true. Then we also want false, true. Right. So I think something like that gives us a pretty good idea of, and all we're getting back is false, true, true, true. So let's go back and evaluate our permutations here. Is this supposed to be that? True, 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 false. True, true, false, true. True, false, true, true. False, true, true, true. Oh, the actual returned nothing that time. Okay. Right. Okay. Let me see here. What is L? For I is less than L. If L equal 1, is that the number of permutations that are possible? Is that the problem I'm having here? Is that my permutations? Yeah, let me try a different implementation here. Well, this is cheating a little bit, but I'm okay with that. My brain hurts. And no, I don't want that. I don't want that. I actually want to leave it the way it is. Let's do MC times length. Let's just see what that produces. Okay. I think we need this to be yeah, just part one. I'm terribly slow right now. I got stuck on this permutation part and um, I know what I want to do and me actually doing it are two different things. But that is life, I suppose. What I'm trying to do is permeate through each possibility of the items. Um, and what I need to do. So I had an attempt that was in place already, and we were focused on just sliding the multiplier forward, but I was missing the part where a multiplier might be in between two additions, so like an addition, then a multiplication, then an addition, then a multiplication, then an addition. And that edge case I was not accounting for. And then I realized that there are far more permutations than what I had. And so what I'm trying to do is create a list of those permutations, basically just taking the total amount of multipliers that I want and creating a list of permutations on that. And so what I'm doing is trying to create that list effectively, and I'm not doing it effectively. So I mean, as you can see here, like this permutation is not randomizing them appropriately at all. So I need to, P is appending bool to ARR, and then it is swapping those out. I think this is our problem. Oh, it's clone. That's what it is. I think this might be our issue. Nope. False in the middle. False at the end. False at the beginning. But not false. No, false at the end. Second position, third position, second position. I mean, this is too many. It's not a deduped list. So is hmm. I see. I see why there's duplicates. So it is for specific positions. Um, but there's duplicates because true is in the same location multiple times. So I'm going to go with this. Let me take this test out. I think if I run this, Yeah, let me run my actual like test here. 4438. There's a lot to put out to the screen. We can dedupe those. I think that would probably help. All right, let me go back to the original test input and the original score, 3749. Okay, so that still passes with the new permutation perspective. Yet it doesn't seem like we're making it through our list in a reasonable amount of time. And so I think part of that is because my permutations, now that I'm generating permutations, there's a lot of duplicates in those permutations. So I'm going to fix that. By doing this. Yeah, that's fine. We'll make one. Um, it's not quite. Yeah, this is not quite a unique function, but yeah. So and then we're going to do u sub bump.sprintf, and we're going to do items equal to in, right? Um, yeah, so this is going to be that. And then u is going to be a slice of t. And then we're going to say for range of k, u equals to append u v return u. And yeah, so now I think what I want to do is when I call get permutations, I yeah. So then if I look at this, test that I created earlier, I commented out. That should cut down on my total number of permutations to be something very similar. False, true, true, false, true, true, false, true, false, true, false. And so let me replace my actual list, my expected with what I got from actual here, because this is hopefully should match up pretty much every time. But let me okay. Well, I can't really guarantee the order, so I'll have to figure that out a little bit. But I think that means that I can come back here, I can rerun this, and my permutations should be much smaller. And then if I come back here, let's look at how we're using these permutations. So no, I don't want to be okay, so that's part of the problem. Okay, I don't want to be looping through. Wait, no, I do. I have the permutation, but I don't want to loop through the permutation or J for the range of numbers. What I instead want to do is I want to reference the permutation. That's why this is taking so long. So what I want to do is I want to say if ni sub of, sorry, if perm sub of ni is true to multiply, then multiply. That's what I want. So if I come back to here, this test should still pass. Undefined J. Okay, hold on. Where's J? We'll do NI. No. Okay, that's fine. We don't need this log anymore. Okay. So this should be going through the superset of permutations now. It's already moving a little bit faster, but it's still kind of slow. One of the things we can do is we know that there is a max number of lengths. So we could pre-calc the permutations based on the slices that we have, and then we won't have to regenerate them each time. That might be useful for each of the like multiplication counts, because I think that's a lot of extra CPU cycles that is not necessary. In fact, let's make a map of string to slice of full, and when we call get permutation, we'll check to see if perm cache bump.asPrintf, and it will just be for lack of a better. And we'll do based on the length. And then we return, we'll say v, okay. We return v. So if it exists, we return it. And then at the very end here, we always set and then we can just return this. I mean, we'll change that to this and this. And now we are optimized a little bit further, because now we won't recalculate permutation every time. We'll just have it cached based on the multiplier count and the size of the array. And that should help a little bit. I think there's another optimization we can do. Trying to think here. If we get through a permutation of, like, say, one multiplication, because we're doing this for addition, but if this here, if we have a subtotal, we go through all of our permutations and our lowest value is greater than the total, we know that we can break, right? So in other words, if we've multiplied once every number with addition the rest, and we know that our lowest value is greater than the total, then we've already gone too far, and it's not going to be beneficial for us to go through any additional permutations with additional multiplication. So we don't have to go any further. So then let's see, for each permutation, if total equal, or I'm sorry, if lowest equals 0 or lowest less than I'll get there eventually. So So that should help us break out earlier. And if we run our tests, we'll still pass. This will help us do less calculations so that after we're done with a set of permutation, if our lowest calculation is greater than our total, we don't have to go to the next multiplier count. We know that that's going to be useless effort. Where is 54741 in our list? It's only 9. That's pretty bad. 9 of 850. And it took us 30 seconds to get there. Pretty slow. What else can we do to optimize this? These are being cached based on the multiplier count and the length. So we know that. We are only looping, we're looping through each permutation, but we're looping through the numbers. Okay. Because we have a permutation and we know that our numbers are fixed, if our subtotal is ever greater than total, we need to continue to the next permutation. Right? So I actually want to do this here. Yeah, we need to do this here. But if I break out where it's higher, I think actually actually I can break here is what I want to do. Because if we get to a point where our subtotal is ever greater than the total, we want to break early. So let's rerun our tests. Just make sure they pass. And then let's rerun it. See if we can get some faster traction here. So we just want to break out of the numbers, right? We won't necessarily break out of the permutation, but we'll break out of the numbers because we know that our subtotal has exceeded our total value. And there's no point in moving further with those number calculations, with a multiplication. And that'll still allow us to calculate lowest. So, well, we made it here a little bit faster. But it still allows us to set lowest so that we can break out of the permutations early. This is still pretty darn slow. What am I missing here? Is there a more optimal way to do these? And I just went the extremely long, painful route. I mean, I'm open to questions. I mean, or suggestions, Kevin. I mean, if you got something you're thinking of or might suggest here, I'm all for it. Or I'm sorry, is it Tadej? I mispronounced your name. I apologize, but I'm open to some ideas here. I understand that this is probably going to work, but I have put the optimizers in place I can think of, and this is still really, really slow. I'm pretty much maxed out. What I don't understand is um, the total number of permutations that I'm going through here. Uh, I don't know. I don't even, I guess I can, if I did this, well, I think I can pull it off. It's just, well, Kevin, did you solve it with the recursively checking valid solutions? Just out of curiosity, I mean, maybe I just took the wrong approach here. This is incredibly inefficient at this point. And I need a better idea of like how long it's taking between iterations. So this will give me an idea here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. It's an incredible. Okay. So where is this at in my input? It's 10. We're at 10 in 28 seconds. Um, I could make this, I could thread it, but I don't think that's going to help at all. So the other thing I could do is so when you say recursively checking valid solutions, I mean all of these solutions potentially are valid, but did you go with like let's just add them up and then try one of them multiplying, and if that number is lower, we try some additional multiplication. But if that number, because it doesn't necessarily have to be in order, it's just do we come to a valid solution? And so maybe the way to look at this is we try multiplying, adding everything, and then multiplying only the larger number, or you know, what's kind of the solution there? Do we try all trues first and then go backwards? I mean, we're looking at processing the second one in the list. So this is the one we're processing right now. And in order to process all these permutations, 1, 2, 3, 4, 5, 6, 7. Yeah, this is just way too many. It's just way too many to get through in a reasonable amount of time. That makes sense. There's got to be a more optimal solution. Um, yeah. So while we're here recursively, it's just not going to work. There's just not enough. It's a brute force method that is just not, at least with the resources that I have here in my local, that are within probably the realm of possibility, of at least a reasonable amount of completion. So if we take a different approach, how else could we approach this? We could, so we start by adding all the numbers, and adding the numbers works or doesn't work. If it's too high, we exit. If it's too low, then we know we can permeate on multiplying. And we can start by okay. So then we could start at index 1 or 0, and we could say, okay, we have 0 multipliers, and we can just recursively pass into trees that attempt different paths of multiplication. So we start with the first one that multiplies here, and then if that is not the total, or and that is not less than the total, then we can then pass one that multiplies here, one that multiplies here, 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 and here, like as different recursions, and each of them could branch off into its own potential recursion that could go deeper in levels of multiplication. I'm guessing, Kevin, that's like the approach that you took, because this is not working. This is too slow. Solution, yes. In this lifetime, no. Like this is where we're still at in my input here. Is record 10. And if I put, the only thing I'm wondering is, am I exiting early enough? Because lowest would kind of do the same thing as going recursive. Just the downside is the number of permutations that has to be calculated to. Okay. So yeah. Okay. Here's another. Yeah, I think the recursive solution is going to be a lot less calculations, because what happens is, in this example, if I have a permutation of true, 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 false, right? Then I have a permutation of true, true, false, true, and then I have a permutation of let's just say true, false, true, true. Each time I go through this permutation, I'm recalculating this index each time. The first index, this is getting recalculated. But in a recursive one, basically it just does the calculation on the first two numbers, passing it down recursively to see if it even gets to the target, right? So then if it would do both an addition and a multiplication on the first two, and then move the index forward, do an addition and multiplication of, move the index forward, do an addition and multiplication of, do an addition and multiplication of, and it would just keep doing that recursively, right? So instead of taking this approach, because we're only looking at those two numbers recursively and we're not doing the permutations, you're going to end up doing way less mathematical calculations that way, because you're not recalculating this value every time. You have it and you're rolling that score forward for each of the branches, which is either an addition or a multiplication. So let's look at that real quick. So we'll give this a get multi-score 2. We'll pull in the total in the ints. I actually think that is the better way to do it. Didn't think about that initially, but now that you've mentioned it. So call this next. Well, maybe not. Let's just look at this for a second. So what you're saying is we'll call it index. Maybe we'll just call I. So number sub I plus numbers sub I plus 1. And I'm going to just do this a little bit different. I'll probably rewrite it here real quick, but this is going to be that yeah, no, your concept here I think is going to work. And so I'm going to try it, but I'm going to try it in a different way in Golang, and I think you're onto it. I should have known when I started thinking about permutations to this extent that it was going to be not computationally possible. Nice, man. I'm glad you just completed day 1. That's awesome to hear. Struggling a bit today, but that's part of the process. All right. So we've got these two. Let's just call it, I'm going to probably switch this up a little bit, but this is just going to help me think about it. And so now we can say something like, if T1 less than or equal to total, it's going to be sum plus, it's not going to be number I. It's not going to be that. It's going to be that or sum times, right? And if T1 equal total, return total probably just return true or false, honestly, because we know whether or not it's there. Talk about that in a second. So this is true. This is false. We know what the total is. And then otherwise it is, yeah, let's actually call this for I. We're not going to do the I plus 1 here. And we'll do something like if I is greater than length of numbers, length minus 1, then I'll get used to this new keyboard eventually. The layers thing is really messing with my mind. Okay, so why isn't this working? Sum of int and int64. We'll just go with, it's fine. I went for that for not a whole lot of reason earlier, so we'll just make this simple. Return true, return false. Otherwise, we are going to attempt No, I don't think so. Actually, honestly, looking at the complexity, Kevin, I do not think that is the right way to go. Maybe you could do like some like caching of the multiplication and addition values of the permutation, but the permutation, though at least just by doing the permutations, you're doing far more mathematical computation. This way, you should be doing less and getting to end branches, I think, much quicker. Not 100% sure, but I want to, I think this is right. So I'm just gonna keep going through this. So get multi-score. Otherwise, we're gonna we'll do if this yeah, and then similarly, we'll go through all these same steps here for T2. And then this will just be return. So then if we go back to part 1, and we can say, instead we'll comment this out and we'll say if get multi-score 2, we've got total 0, numbers 0, a little ugly, but I'm okay, score plus equal total. And then it's fine. That should be okay. Expected 3749, actually 0. So what did I do wrong? So if I is greater than the length of numbers minus 1, we return false. That's just a guard clause. Otherwise, we take the sum of plus our number I, which would be the 0 index, add that. And if our T1 is equal to our total at that point, we return true. Otherwise, we return false. And then we take our T1 is what we need to pass here, and T2 is what we need to pass here. Try that again. All right. If this works, I'm gonna be mad at myself. And that's okay. We can be mad as long as we get the right answer, which we don't. Okay. So what are we missing here? So what I'm doing here is I'm only checking the next index. But in order for this to work, you think it needs N64? We can change it to N64s. So the reason why I went in is because by default on a 64-bit system, it should be N64. I converted them to N64s earlier, and I'm pretty sure this number is already higher than N32. But I will change it to N64s just to make sure I'm not missing something here. And I can fix that by doing the numbers in the actual sheet. I think are just the actual numbers are pretty small, so we're going to go with that, and we'll go with this. But I think the answer is that I'm only recursing to the next one, right? No, that should be okay. Yeah, I think we're okay. But let me just do it just to make sure, and that way we know that it's not a problem there. 75,799,946. Yeah, same value. So let's think about what I'm doing here. Let's go back to this, and let's look at the branches that I'm creating. So we'll erase all this. And so the first branch we would create is 1 plus 2 and 1 times 2. Right now, this sum is going to the next one, and this sum is going to the next one. It's actually not that. It's, well, okay. I think that's one problem then. So it's technically 0 plus 1, right, is the first branch, and 0 times 1. So that's the first set, and then this sum goes to the index of 1, and we get 1 plus 2, and we get 0 plus 2, which is very interesting. This should not be happening. And we can just quickly guard against that, just to make sure that's not the problem here, or part of the problem. And so what we'll do is if we'll just say here, if I equals 0, return false. Yeah, because the first branch that comes into here is going to go and create the next branch of 1 plus 2 and 1 times 2, right? So if we come back here, if I do that, this will be 0 plus, and then it'll be 1 times 2 in this example, which would be 3 times 3 and 3 plus 3, and also 3 times 3 and 3 plus 3. Just as an example, the ordering here, but this branch would be 2. Actually, I'm sorry, this would not be that. This would be 2 plus 3 and 2 times 3. So I think that only gives us moving forward like one of the indexes, right? But I actually need more than that, because if we get to a value of an addition at the 1 and 2, I also need not just 1 plus 2 plus 3 and 1 times 2 plus 3 and 1 times 2 times 3. I think actually that is right. So if I add this guard clause in, seven, 5, 7. Did I try that number? Now I'm getting a little crazy. Oh, that's wait 3 minutes. Okay. Probably. Yeah. Okay. If I is greater than the length minus 1, return false. If I equals 0, return false. All right, what's the issue with my logic here? Where'd I go wrong? Index 0, number 0. I is greater than the length of numbers minus 1. We return false. There's no match if the total matches for T1 or the total matches for T2. Let me just copy this because I was in this file earlier. Make sure I didn't break anything. I suppose that with this approach, get multi-score, the new one, I actually don't need to do the addition totaling at all. leave that is also true. Three, 6, 9. Is that my problem? Why did I get a different answer when I removed the addition totaling? Okay. Because this is going to do our addition. It's going to take our sum plus the numbers I. Ah. That's the problem. That is the problem. So what I'm doing right now is once I get to the total, I'm exiting. But just because I get to the total doesn't mean that we're there. I don't want to exit. I don't want to exit here. And I don't want to exit here. I only want to exit when I'm at the end of the list, right? So if sum equal total, we return true. Otherwise, we return false. Yeah, return this. Okay. Okay, so why is this not working? We want to iterate, right? All the way to the end. Okay. So that is why. Okay. Yeah, let me just change this around a little bit. Make this a little bit simpler. I'm still gonna leave that in there actually. Get rid of that. And then we know that if we ever exceed, we can Now I'm in a penalty box. All right. So what I did was I changed this so that if we enter in here and our sum is greater than our total, we return false. If we reach the end, we're going to return whether sum equal total, because we can't just stop when we get to the total. We have to go all the way to completion. And then I remove the variables. That way it's going to check at each time here. And I do think there's this case with the multiplication where 0 times the initial number doesn't make any sense. So if we are at index 1, we're not going to attempt to multiply the sum of 0, because I think there might be a weird edge case there. So we're just going to wait and see if we've got 4 minutes and 13 seconds left. So at 3:10, we will give it another go. This looks so much prettier than the permutations too. I don't know why I didn't think about going from a just looking at two numbers at a time perspective. That's such a better approach than the permutations. We could probably do some caching with the calculations here, but I don't. This is way more elegant. And we still have part two. Still have part two. I don't know. Yeah, I can clean that up. I don't know if I guess I don't know what I don't know. Two minutes. I'm impatient. All right. I suppose we could optimize it even further by choosing. No. I mean, we could try to be choosy about which route we take, but I think don't think that'll matter. I think I could probably fix this by. Yeah, I don't know. 57 seconds. I'd like to see if I could clean this up even further and just do like a. Because I could just return get multi-score or multi-score, and I think that would probably also work. But I don't want that 0 condition in place, so. Okay. Finally, part 1 done. How do I mark this here? I'm gonna do like a little, yeah, okay. Part 2. The engineers seem concerned the total calibration result gave them is nowhere close to being within safe tolerances. Just then you spot your mistake. Some well-hidden elephants are holding a third type of operator, the concatenation operator, combining the digits from its left and right inputs into a single number. For example, 12, 345 would become 1, 2, 3, 4, 5. All our operators are still evaluated left to right. Now, apart from the 3 equations that can be made true, yeah, hooray. It's a much better solution, much faster true. Try true using only addition and multiplication. The above example has 3 more equations that can be made true by inserting operators. Can be 15 and 6, 156. Can be, okay, can be made true using, okay, adding up all 6 test values, okay, 11,387 for part 2. All right, so now I actually think now that we have this solution is pretty much just more of the same. But let's go ahead and create our test input. And I did mess with the test input at one point, so I'm just going to recopy it and make sure I've got the original test input for this subtest here. And let's see here. Yeah, thanks for your help, Kevin. I appreciate that. I was really on the struggle bus there. So let's do this then. Let's try to be at least salvage this somewhat and be elegant about it. And let's pass in yeah. So we're going to add this and we're going to say if and we'll do a switch and we'll do a case of, we'll go ahead and do plus. We'll do a case of yeah. And we'll do something here, and we're going to add this to here, and we're not going to return here. We're actually going to continue, and we're going to return false here. So now we can have our same function for get multi-score, but we can have different operators added to it. And so in this case, we'll do a bump.sprintf, and we will just simply do a %d. We'll pass in, ooh, that's interesting. That, wait a second. Hold on. Did I move too fast with this refactor? Six times 8 concatenating 6 times 5. Okay, but let me see what that means. So 6 times 8 is 48. It's 486 times 15. Ah, okay. Good. So the concatenation happens after this. It's not concatenating this, then doing the whole operation. It's this, and then concatenating that sum with this, which equals this, which is exactly what I'm coding here. Right. Okay. So then this becomes sum, and then numbers sub I. And then yeah, so we're getting there. And then so this is going to be string for dot a to I, and we're going to call this and we'll call this C. Yeah, this will be fine. Yep. Right. Let's check our tests. Oh, yeah, so that makes sense. So now if we will go back to our tests, where are we at? Test file. Okay, that's fine. We'll put the operator in here. So if we go to part one, get multi-score. We have plus, and we have multiplication. And so if we rerun this, we are still failing. Why? Get multi-score for operator and operators. Operator is a string, case plus. Because we need to pass operators. Yep. Okay, cool. And then if we go to back to our part two, our part two really is just part one. But I'm going to copy it. I might have done this a slightly different way at a different time, but nobody got time for that. Right. Okay. Not equal. plus multiplication and pipe. Oh, I do. Also, I don't want to like add I to it, so I'm also going to skip if it's on the first one because we don't need a zero index here as well. But all right. So 1 should be the same as 2. And then we'll make sure part 2 is enabled. We'll run them both. That was fast enough. And part 2 is complete. All right. Well, I redeemed myself a little bit by, at least in my own mind, I'm going to get rid of this. Let's do a little bit of refactoring so I feel better about myself when I go to sleep now, because this was terribly longer than I expected it to be today. But that's part of the process, right? We'll get rid of these old solutions that don't matter. And we will make this all nice. All right, awesome. Well, that's part 2. Man, I struggled quite a bit today and I just didn't see it, but that's part of the process, is figuring it out and logically thinking through it and coming up with a better solution. Thanks, Kevin, for your help. That did help quite a bit. Kind of set me on the right track here. Let's just take a look and see where everybody's at. This is usually pretty interesting to look at. I usually look at this and kind of give an idea of where we're at and the complexity of the problem. I find it interesting. So the way this chart works is that those who are in the gold have finished both, and those who are in the silver have finished just the part 1 without finishing part 2. We can kind of see how, as time progresses, less and less people complete them. I got wrapped around the axle tonight. That happens. I should have known when I started going down a permutation path that it was going to be not efficient enough, or it was going to be poorly not efficient. And I sort of got pulled down the path because I had a fast implementation of it that was only doing half the work. So now I have a multi-score function that is really a get score function, and I'm going to just call it that, because it does addition as well, which is nice, and we ended up with a better solution here. And we'll refactor this a little bit and make it nice. So I thank you all for hanging out. It was fun. Again, a bit tedious, a bit of a struggle bus today, but again, that's part of the process. I'm here to learn. I'm here to get better. And I thank you all for joining with me and sticking it out. Please like and subscribe. I plan to do more videos like this. I plan to dive into some other topics. I'm already kind of looking into the LLM and AI space. And I have a chess battler that I've been working on where I have some very interesting goals and aspirations for that, where I will be looking at the data and using Stockfish to analyze LLM's chess moves, and just kind of being able to look at it and say, okay, what is the cognitive ability of this tool set? And, how well is it going to make decisions and moves? And I think it's kind of a fascinating place to be because, LLMs are not cognitive. They really aren't. And the reasoning is not based on reasoning, it's based on predictability of output, based on inputs. So, they train them on inputs that look like reasoning to give reasoning output, but they don't reason. They just are really good at prediction. And so something like chess, where it's like a drawn out strategy game, kind of really highlights, when they start just making guesses, right? And they're not really thinking about the overall complexity of the game. And so one would argue they're not trained on it, but the more you train, the more just predictive it becomes. So they tend to be really good in the early game because there's lots of documentation on early game. But when things start getting a little bit more randomized and non-traditional, they don't really like take advantage of openers and things like that. But it's just an interesting thing. So I appreciate everybody hanging out, and thanks for tuning in, and see you next time. Y'all have a good night. Bye.